welcome back to my channel. We're going to continue on talking about simple machines in chapter 4. This is lesson 59, and we're going to be studying pages 84 to 87. The two simple machines that we're going to be talking about are called the wheel and axle, and we're going to be talking about the pulley. Let's get right to it, and I'll demonstrate each one of these simple machines so you can have a better understanding of them. This is another simple machine we often use often is a wheel and axle. A wheel and axle is a wheel with an axle or rod, or you can think of a metal stick running through the wheel. We can identify some wheel and axles easily. The wheels on a car, bicycle, or wagon all turn on an axle we can see. Other wheel and axles are not as easy to identify or to name or see. For example, a round handle on a faucet is a type of wheel and axle. The handle works as the wheel, and inside is the axle. Even the screwdriver is a kind of wheel and axle. The handle is the wheel, and the shaft is the axle. We can use a wheel and axle in two ways. The effort can be applied or used to the axle to make the wheel move. This way uses a greater effort to turn the axle, but the wheel moves a greater distance. The wheels on a car, bus, or bicycle work in this way. The effort can also be applied to the wheel to move the axle. Since the wheel moves a greater distance, less effort is needed to turn it. As the wheel moves a greater distance, the axle moves a shorter distance, but with greater force than the wheel. This is how a steering wheel and a screwdriver work. So before we go on to the next page, I'll give you a demonstration or help you to understand the difference if we put the effort on each one of these parts of a wheel and axle. So if we talk about the wheels on a bus or wheels on a car, okay, they're on the outside of the vehicle. In this case, the force is being applied to that rod, the axle. And what was something that we discussed that you need to remember in this chapter? Greater distance, less effort. Okay, remember that. Greater distance, less effort. So if you look at the axle compared to the wheel, which part is moving a greater distance? Well, of course, the wheel is. It's larger. All right, so that axle is moving a shorter distance. So if we're moving a shorter distance, does it have greater effort or does it have less effort? If you said greater effort, that's correct. So that axle is moving with great force or great effort and making that wheel move a great distance. So that's on a bicycle, on a car, that's how those wheels work. But inside, for instance, a car or a bus, you'll have the steering wheel. Maybe you've seen your mom and dad drive a car, and do you see them going, really turning that wheel? No, they usually turn it quite easily. All right, so the steering wheel, of course, is the wheel, and you don't see that part, but inside the car, there's an axle. Now, the axle and the wheel, which is moving a greater distance. Well, of course, the wheel, it's much bigger. So if we're putting the effort on the wheel that's moving a greater distance, is it going to be greater effort or less effort? Well, you said less effort, that's correct. Okay, why? Because the wheel is moving a greater distance. Okay, so it's really easy to turn that steering wheel. All right, so that's the difference between applying the force on the wheel and or applying the force on the axle. Now, something you might not think is a wheel and axle is this. This is a screwdriver. Okay, and you think, wait a minute, that doesn't go on a car or a bus, which is correct, but it still works as a simple machine as a wheel and axle. For instance, if I had a screw to put in and I just use my fingers, you think I'm putting my fingers around that little screw that's a very, very short distance, and so therefore I would have to use a lot of what? Force to move it. But in this case, if I grab this handle and I put the shaft here against the screw and I turn it, now when I'm putting the effort here, is it moving a greater distance or is it moving a lesser distance? Well, this part is moving a greater distance. So what do we say? Greater distance, less effort. So it's so much easier to turn that screw if I have this simple machine. It's a wheel and axle. This part, the handle, is the wheel, and the shaft is the axle. All right. Let's move on to the next page. Something else you might not think is a wheel and axle is the doorknob on a door. Okay, and it gives you a picture in here. The outside is the wheel, what is turning, and the inside, what you don't see, is the shaft. Now, what part do you turn? The door or the wheel, which is the greater distance. The wheel. So is it hard to turn that axle? No, because you're turning that wheel at a greater distance. Greater distance, less effort. Let's read about it. A doorknob also works this way. The knobs on either side of the door are the wheels. Inside the door is the axle. As you turn the wheel, the axle turns. The axle moves the latch in the door. Long ago, people found that a wheel and axle can also make work easier because it reduces friction. A rolling object experiences less friction than a sliding object. The less friction there is, the easier things are to move. So let's go back to that car idea. Now, if you think about a car, how many wheels are on the outside of the car? Well, you said 4, that's correct. Now, one of the forces that we experience every day is friction. Okay, gravity is the other one. So let's think about it. Let's take away the wheels of a car, and the car is flat on the ground. Now, more surface is touching the road. And let's say we attach a rope to the end of the car. Now, would that move very well? Why? No, because there's more surface area touching the road, which means more friction, which means more resistance to move it. It wouldn't move very easy. However, if you lift the car up and you place it on 4 wheels, now much less surface area is touching the ground. Now, of course, the wheels roll, but let's say the wheels didn't roll. It would require less force. Why? Because less of the car is touching the ground. Less friction is created. All right? So the idea, not only the wheel turns to make work easier, but it lifts the car off the ground to create less friction. So obviously it would make the car move easier because it has 4 wheels. Let's keep going. Gears are wheel and axles with teeth that work together. Each gear has teeth around the edge of its wheel that fit together with the teeth of another gear. When force is applied to one gear, both gears turn. One gear turns the other. Gears are used in many tools and machines. A handle on a can opener may use gears to turn the cutting device. Gears also make the hands on a clock move. So if you ever get a chance to look inside a clock or a watch, you'll find these little tiny gears. And when it says teeth, it's kind of like the pointy parts of the gear, and they fit together perfectly. So if I put the effort on one gear, all of those gears turn. Okay? So there's a picture of a gear in your book. Now, I do want to give you a little close-up. See here? Right here? You may not use this, or you may use this. This is called a can opener. And a can opener uses gears to turn the cutting device to open that can. Now, today, many of our cans already have a pull top, and you can pull it back, and it's really easy. But before, we'd always have to use a can opener to get what's inside of the can. Let's move on and talk about pulleys, and this will be a lot of fun. We'll talk about this in just a moment. All right, page 86. It says a pulley is a simple machine that has a grooved wheel. Now I'm going to show you, I'm going to get up a little close with here. This is a pulley, okay? It's kind of almost like a wheel and axle, okay? But it's a little different. I'm going to show you the difference, okay? Can you see here? There's a space between these two parts. Well, that space is called a groove, and a rope or string goes in that space. Let's keep going. A pulley is a simple machine that has a grooved wheel with a rope that fits in the groove. On one end of the rope is the load, or what we're lifting. The effort is applied to the other end of the rope, or the force that we use to move the load. The load moves as the effort pulls on the rope. Pulleys are sometimes used to help lift heavy or large objects. Sailors use pulleys to raise sails on a ship. Large construction cranes use pulleys for lifting. You might also use a pulley to raise a flag or to raise or lower window blinds. There are different kinds of pulleys. One kind of pulley is a fixed pulley, okay? And I have a pulley up here, and I'm going to switch it with this one. All right, so I have my pulley up here. This is what we give an example as a fixed pulley, a fixed pulley. A fixed pulley is attached to something and cannot move, meaning it cannot move up and down. Only the wheel on the pulley moves when the rope is pulled. A fixed pulley changes the direction of the force needed to lift the load. The same amount of force is needed, but the direction of the force has been changed. A fixed pulley makes work easier because you can pull down. Now, remember, with any simple machine, it's going to make work easier in two ways. The first way, it's going to make the effort or force less needed to move the load. The second way, it could change the direction of the force. Now, what force do we always work with every day? You guessed it, gravity. Gravity is pulling us down. Now, let's say if I'm lifting a very heavy load, like say a bucket of water, and I'm pulling up, I'm working against gravity. But if I attached a pulley to it and I pull on a rope, what direction am I using my force? I'm pulling down, so I'm working with gravity to move the object, and it makes work just a little bit easier. That's with a fixed pulley. Okay, let's keep going. Another kind of pulley combines fixed and movable pulleys. Now, we're not going to talk a lot about a movable pulley, but if I put my rope up here and I had these pulleys here, these pulleys would move up and down like this, okay? If a pulley can move up and down like this, that's called a movable pulley. The third part that we're going to talk about is when we combine a fixed pulley up here and a movable pulley, it makes what we call a block and tackle. I say that, block and tackle. A block and tackle is a combination of both kinds of pulleys. The more pulleys you have, the easier it will be to move the load. Let's go ahead and continue reading. This kind of pulley is called a block and tackle. In a block and tackle, the fixed pulley changes the direction of the force because the rope moves a greater distance, less effort is needed. So that rope has to travel so much more distance to move the load. But remember, greater the distance, less effort. With each pulley added to the block and tackle, the rope moves a greater distance. This means less force is needed. All right, I'm going to demonstrate this. Comparatively, before we put the pulleys all together and add them all together to make the effort less, I do want to show you the difference would it be if I just picked up the load with gravity working against us, if I just put the load on our spring scale. Okay, so I'm going to show you here and see the force. See, here's the load, and I'll get up closer. You see that it's like at 0.9 with gravity working against us. All right, and you'll see as I progress and add more and more pulleys how the force is reduced because that rope has to move a greater distance. All right, so here I have a little bit of a load. It's a rock in a little cup, and I'm going to place my rope inside. Okay, and I'm going to attach it to my wheel. All right. So simply, I'm just pulling up and down on the rope, and it makes it easier to lift the load. Why? Because I'm working with gravity instead of against gravity. So something that we can do to measure work, and we mentioned this before, is we can measure work or measure force by using what we call newtons. And I have this special little device, little measuring tool. This is called a spring scale, and it can measure up to 1 Newton of force, okay? So I'm going to put here on the end of my pulley, okay, I'm going to put it here on the end of my pulley. All right, I'm going to turn my camera just a little bit so you can see. Okay, when I'm pulling this, you can see it's almost a full Newton. It's like right here, it's like when it's pulling, it's like 0.8. So it's not quite a full Newton when I'm pulling on this rope. So 0.8. Now let's see what happens when I add, and I'm going to turn the camera back, when I add more pulleys. Remember, the greater the distance, less effort. Okay, so I'm going to pause this video and I'm going to switch this around and I will come back. Now I have added a second pulley. I haven't used the third one yet. I've only added 2. Okay, so now that rope is moving a greater distance. Now, let's see what happens when I apply the force, okay? I don't know if you can see. I try to move the camera a little closer. Can you see that less effort is being used to move that effort? I mean, to move the load, all right? So right now, it's at about 0.5 newtons, 0.5. So the first time was 0.8. The second time was 0.5 because I added another pulley. So I'm going to stop it, I'm going to switch it around, and I'm going to show you what happens when I add a third pulley. Changed it up, and I've added the third pulley. So I'm pulling up and down. It's quite fun to play with these. You can definitely feel with your hand if you play with these at home that it makes a big difference in how much force that you use. So when I had 2 pulleys, it was at about 5.5 newtons, or how much force we use. So let's see what the difference is when I have 3. Okay, it's about at 0.3. 0.3. Okay, so it keeps going down with more pulleys that I use. Okay, so you can see how when the rope moves a greater distance, less effort is needed to move the load. Okay, so this brings us to the end of this lesson. I hope you've enjoyed it. Something that you can do for homework is page 87, the 2 questions, and activity manual, page 67, to help you understand more what we learned today. I'll see you next time.